All right, so I'd like to go over a little bit of the math of the statistics that we'll be using in this lab. So the first thing we'll be using, which hopefully all of you have seen before, is the average, which we label as x bar. And the average is just the sum of all of the numbers divided by how many numbers there are. So we can write that as x1 plus x2 plus dot plus dot plus xn, where n is the number of numbers, over n. And the way that it's written in the manual is, this is called summation notation. So if you see a large sigma like that, normally that means you're doing a sum, and it will be usually written with some variable that starts at 0 or 1, or you can have it start at whatever you want. I mean, most of them will start at 0 or 1, but sometimes they won't. So, and then two some numbers. So in this case, we're using n as the number of measurements that we have that we're averaging. And so if we just say this is over xi, then we're just summing. So we're substituting 1 in for I, and then we're substituting 2, and then 3 all the way until we get to n. So that means the same thing as here with the ellipses. Let me redraw this so that the ellipses are actually on the bottom like they should be. And obviously, for the average, we need to divide by n then. So yeah, if you haven't seen that before, hopefully it makes more sense now. So then we have the standard deviation. So the standard deviation of x is the square root 1 over n minus 1 sum I equals 1 to n of xi minus x bar squared. And so hopefully you know that when you sum things inside of a square root, you can't bring the square root inside, so that's why we have to do the sum inside of the square root. So there is this quantity on the inside of the square root is known as the variance. So the variance is just the standard deviation squared. And I'm going to use that a little bit in a moment to show that, or show why the final equation is true. So the standard deviation, this is the standard deviation per measurement. So if I want to know where my next measurement will land, like let's say I've done 50 measurements, and I want to know, what is the range that the next measurement will most likely have. Then I would use the standard deviation, and it's a 68% probability that the next measurement will land plus or minus 1 standard deviation. But the thing is, when we're doing an experiment, what we want to know is how accurate our final result is. So, if we're taking an average, we don't care about what happens with the next measurement. We care how close our average is to the true average of whatever we're measuring. And so for that, we use what's called the standard error of the mean, which is basically the standard deviation of the mean. And we call that sigma x bar. And that is just equal to sigma x over n. So quickly, I'm going to go over how or why, or I forgot a square root, why this is true. And to look at that, we are going to first consider a couple things about the variance. So like I said, we're going to write var as variance of x is just equal to the standard deviation of x squared. And there are a few points that, some details here where we are assuming, when I'm doing this, that our standard deviation is the true standard deviation of the sample, really of the full sample. So if we're taking, measurements of a limited sample, then technically our standard deviation is not of our sample is not exactly the same as the true standard deviation of the entire population, because we, haven't sampled everything. So keep that in mind, but this generally works for if you have a large number of samples. So if we put, and let's write what this is exactly. So this is 1 over n minus 1 sum over I xi minus x bar squared. So we'll need to use two things. Bar of a times x is equal to a squared bar of x. And that is pretty easy to see. If you plug in a xi there instead of just xi, then you square it, and because it's multiplying every term, you bring it outside and you get an a squared outside. So var of a of x is equal to a squared var of x. Or I should say variance of x. Anyway, now what we need is that if we have different groups of numbers, so let's say we have a group 1 and group 2. So what we want to know is if we add these groups together, what happens to their variance? And since you're summing over each individual term, if these have the same number of measurements, then what you get is just that this is equal to the sum of their variances. So the variance of their sums is equal to the sum of their variances. All right, so now what we want to do is we want to look at the standard deviation or the variance of the total. Hold on one second. All right, so if we say that the total is just the sum here, without dividing by n, so let's write this. I'm just gonna write it here because I want to save room. T is just the sum T is the total. It's just equal to n times the average. What we're going to do is we're going to take the variance of T. And this is the variance of the sum of each of these numbers. Which is then the variance of each summed separately. So we're just using this property down here. And now the variance on average of each of these samples is going to be our standard deviation squared. So what we get is we have n of these sums, and each of them is on average the standard deviation squared. So we have n times sigma squared. So now all we need to use is that this bar of x bar is equal to bar of t over n. And as we showed here, this is the same for division. This is 1 over n squared. And then we substitute this in, and we have n sigma squared. And so we get sigma x bar equals square root of the variance of x bar equals, and we just get sigma x over square root of n. I hope that makes sense a little bit. There are some details that I kind of glossed over. For example, assuming that the average of all of these variances will be sigma, but I mean this is basically our standard deviation here, as we defined it over here. So yeah, I just wanted to show that and give you some idea of why the standard deviation of the mean is the standard deviation of the measurements divided by the square root of n.